Hi students, in this video we will discuss linked list, create and display. That is creating a linked list and displaying the elements of linked list. So in last session we discussed that, or in last video we have seen that collection of nodes is known as linked list, and a node is a memory location which contains both data part and address part. This example for a node, let me draw a node. So here let us assume this is a node. So this node contains both the data part and address part. Both data part and address part. Here we call this as a data part, and here this as a address part. So for address part, it is a pointer as it stores the address of next node. We give the name next. So here this is the memory location of a node, and this node will contain some address. So here when we create a node, it contains data part and next part. Data part can be any data type which we want to store, and the next part is a pointer. It should be a node type of pointer which will store the address of next node. Then now first, how to create a node. So when you create one variable, so it should have two memory locations. One should be a data of, it can be integer, character, float of your choice, and the other one is next. How to create this node first we will see. So in one memory location, two parts. It is possible only with either arrays or structures. Arrays means both must be of similar type. So we use here structures because we can store different data types. This is integer and this is pointer, which is possible only with structures, different data types. If you want to store same, we can use arrays, but here we want to store different data types, so we are using structures. Now so let me write the code here to create a linked list. In order to create a node, struct a node, then every structure ends with semicolon. Here I am creating int data. So here this data is integer type. We can store only integer values in this data, as I have declared it as integer. Now this should be a pointer. So which type of pointer? This should be a node type of pointer because it will store the address of another node. So struct node star next. Remember. So here whenever we create one node, so for that node memory will be allocated for data part and next part. Data part we will store integer value, and next part we will store the address of next node. And here if you want to store float values, declare it as float. You can store float values, that is possible. Now this is a how to create a node with the help of structure variable. Struct node star root equal to null. Here in linked list we use a variable called either root or head or first, but most of them prefer using root. Here root is a pointer. Which type of pointer it is? Node type of pointer. So here this root contains only one memory location because this is a pointer. It will store the address of first node. Root is a pointer. It will store the address of first node. Initially when there are no elements in the node, its value is null. Null means 0. Its value is null. N-U-L-L you can take. So here we have created a structure type of structure we have created for a node. And here we have struct node star root. Root is a pointer which will store the address of first node. As there are no nodes, till now we have not created any nodes, so root value is null. Now let us see create function. So in the create function, let us discuss create function more clearly here. Okay, let us write here. Create. Here let us use void create. Create function is used to create a linked list. Now here inside this create function, take two variables called, one is new node, which is used to store the address of newly created node, and another pointer called last, which is used to store the address of the last node in the linked list, which is used only in create function. Then declare one variable called int n, which is used for storing the data n value. Now what we do here is, whenever user wants to allocate the memory or create a node, dynamically we will create the node. Here I am using one loop called while one. What is while one represents? Infinite loop. While one represents infinite loop. Here repeatedly it has to create the nodes. At one point we will tell, at that point it has to stop. That is, printf enter the data and -1 to stop. That is, whenever user enters -1, it has to be stopped. Then scanf %d comma %n. This is accepting the data from the user. That is, whenever user enters the data. Now I am removing this part, I will continue here. Whenever user enters the data, then check the condition. If n equal to -1, so what we need to do? Stop. Come out of the loop, that is break. If n equal to -1, come out of the loop. Otherwise, what we need to do? Create one new node. Otherwise, create a new node. New node should be created. So here, in order to create a new node equal to struct node star, this is for typecasting, malloc size of struct node. This statement is important. So this malloc function will allocate the memory dynamically. How much memory? Size of struct node. How many bytes this node will occupy, that much memory will be allocated. And malloc function will return void pointer. It has to be converted to destination type of pointer. So this destination pointer is of node type, so we have to convert it to node type of pointer. So when this statement has been created, what happens is, with the name, so malloc function will create one new node. Let us assume that this is the new node it has created. So that node will have some address. Let us assume that its address is 1000 or any value you can take. Let us assume address is 1000, and that 1000 will be stored in new node. That is, new node is pointing to this 1000. New node is pointing to 1000. That is, this node it is pointing. Now I want to store in this new node, user has entered some data. That data I want to store, that value I want to store in the data part. So whenever a new node is created, so immediately what you need to do here is, whenever a new node is created, so new node of data, equal to n and a new node of next equal to null. Here whenever a new node is created, immediately what you need to do here is, this is the statement for creating a new node. After creating the new node of data equal to n and new node of next equal to null. Why? Because data, let us assume n value is first time it is storing, so let us assume it is 10. So new node, because pointer to structure variable accessed using indirect access specifier, that is minus greater than. If it is a normal variable, dot operator we will use. As it is a pointer, we are using minus greater than. So what we need to do here? So 10 will be stored in the data part and null will be stored in the next part, because there is no next node for this when it has created. Then after that, now what we have to do? We need to check whether this is the first node we have created. If it is the first node we have created, this value or this address will be stored in a root pointer. So what we need to do here? So this statement, if root equals to null, if root equal to null, assign root equal to new node. Assign root equal to new node. Now tell me, what is the value of root initially? No element, so its value is null. So new node means 1000. This 1000 is assigned to root. So what happens here? This 1000 is assigned to root. So this 1000 address is assigned to root. That is root. Now 1000 is the first node we have created. 1000 is the first node. Then after that, else. What is this else part? I will explain. I will write the code here later. Then after that, I am writing another statement. Last equal to new node. Last equal to new node, and I am closing the loop. Last equal to new node, and I am closing the loop. Here we have else part is there. Okay, it is right. Last equal to new node, and that else part should be closed. Here this while loop should be closed. Here I am closing this while loop here. Now this part I will write the code later. Now while, so here I have created one new, if is true, so control will not go to the else part. So last equal to new node. So what happens here? This address is also stored in last pointer. This address, now last is also pointing to first node. Last is also pointing to first node, or the address of the first node is also stored in last. Then after that, again what happens here? It comes to while loop. Enter the data -1 to stop. Enter the data and -1 to stop. So let us assume that now user enters 20. User enters 20. Let us assume user enters 20. Then 20 equal to -1, false. So new node equal to, this statement will create one newly created node. Then here one new node will be created. Now let us assume that this is one new node is created. Now this new node contains both data part and address part. So here it contains data part and next part. Now let us assume its address is 2000. What is the address of this newly created node? 2000. And now what happens here is, this new node will point to, that is equal to new node, means this new node will point to newly created node, that is 2000. Now new node is pointing to 2000. After that, new node of data equal to n. What is the value of n? 20. So 20 will be stored in data part. Then after that, new node of next equal to null. So null will be stored in the next part. Here we have 10 and null. Then root equal to null. What is the value of root? Already 1000 is there. 1000 equal to null? No, false. So it comes to the else part. Now here we need to write the code. Now tell me what we need to do. So here this new node's address, what is that? 2000. This 2000 must be assigned to 1000 of next. So in this way we need to link. How it happens? Here what we need to do here is, now here in the else part, so what is the pointer pointing here? Last pointer is pointing here. What is the pointer? Last. So in order to write here in the else part, last of next equal to new node. Last of next equal to new node. This is the code in else part. Now here you can see what is last? 1000. 1000 of next equal to new node, that is 2000. This 2000 is assigned to 1000 of next. Now it has been established a link. Then after that, last equal to new node. Now what is the last node? Now we have two nodes are available here. So now which is the last node? 2000. Now last will point to 2000. Last will also point to 2000. Similarly, if you enter once again, what happens? Again it comes here while 1, enter the data -1 to stop. Now let us assume that user enters 30. What is the value user is entering? Let us assume 30 user enters. So what happens here? 30 equal to -1? False. So one new node will be created. Here one new node will be created. So it will point to this node. This is the new node. So for new node equal to new node. So here let us assume now new node is pointing to this node. So this is new node. Let us assume its address is 3000. Let us assume its address is 3000. What is the address? 3000, which contains both data part and next part. Now what happens? New one of data equal to n, that is 30 will be stored here. Then after that, new node of next equal to null, null will be stored in the next part. Then if root equal to null, what is the value of root? 1000. 1000 equal to null? False. Goes to the else part. Last of next equal to new node. What is last? Now 2000. 2000 of next equal to new node, that is 3000. This 3000 will be stored here. So here this n will be removed and here this null will be removed. 3000 will be stored. Now last equal to new node. Now this last will point to this new node. In this way, whenever the number of nodes we create, it will be pointing to each other. This is how to create a linked list. Now let us see the code to display the elements of linked list. To display the elements of linked list. Now let us see how to display the elements of linked list. In order to display, the code is very simple. What we need to do here is, here inside display function, take one temporary variable struct node star temp. This is for iterating part. So temp equal to root, because root we should not move to the other nodes. Temp equal to root, meaning now temp is pointing to first node. Now what happens here? So we will temp is pointing to root means first node. We will display temp of data, then we will move to next node by the help of temp equal to temp of next. Then after this again temp of data we will display, then we will move to next node using temp equal to temp of next. Then again temp of data we will display, temp equal to temp of next. This is null, so there is no next node, then we will stop iteration. So temp equal to root, meaning temp is pointing to first node. So while temp not equal to null, while temp not equal to null, so what we do here is printf temp of data, use the format specifier and all. Then temp equal to temp of next, temp equal to temp of next, that is temp will move to the next node. So here this process will be repeated. Initially first node temp is 1000 not equal to null s, then it enters into the block. Then after that printf temp of data, that is 1000 of data, 10 will be displayed. Then 1000 of next 2000, 2000 not equal to null s enters, so 20 will be displayed onto the screen. Then again 2000 of next 3000, so 3000 not equal to null s, 3000 of data 30 will be displayed. After that 3000 of next null, null not equal to null false, it comes out of the loop. This is how to display the elements of linked list. Now we will see the execution part. Here I have already written the program. Now let us see the execution. So this is linked list. Here struct node star next int data, then struct node int data, struct node star next. Struct node star root equal to null. Here root is a pointer, it stores the address of the first. Initially it stores the address of first node, it should store, so initially it is null. Now void create, the create function is used. Struct node star new node and star last. Then int n while 1 infinite loop accepting the data from the user. If n equal to null, it comes out of the loop, otherwise the process will be repeated. This statement will create a new node of data equal to n, new node of next equal to null. If root equal to null, root equal to new node, else last of next equal to new node, then last equal to new node. So here this process will be repeated until the condition becomes false. Then close the create function. Now we have display function. So if root equal to null, displays list is empty, otherwise elements of list are temp equal to root, while temp not equal to null, so printf temp of data will be displayed, then temp equal to temp of next. Then if temp not equal to null, displaying one arrow between the nodes. Then int main clr clears the screen, create function and calling the display function. Let me run this program. Enter the data -1 to stop, 10, 20, 30, 40, any values you can enter, -1 to stop. So here it displays elements of linked list are 10, 20, 30 and 40. Okay, thank you. For more videos, if you have not subscribed, please subscribe for more videos. Thank you. We'll see you in next video.